In the summer of 2006, the Arizona Cardinals Football Club will open their season in one of the most technologically advanced stadiums ever built. With a bold, modern design, including a retractable roof and a roll-out natural grass playing field, the facility will set the standard for football stadiums around the world.
It's going to be like nothing else in this country as a stadium, as a piece of architecture.
In February of 2005, with the stadium nearly halfway complete, Hunt Construction Group was faced with the giant task of raising two massive Brunel trusses, nearly 200 feet in the air.
All right, we're lifting, fellas.
The trusses, with a combined weight of 11.2 million pounds, form the backbone of the roof.
It's in good shape. That is one hell of a structure out there.
Over 5 cold and rainy days, a handful of engineers and ironworkers descended on the West Valley of Phoenix to attempt what would be the largest roof raise in North American history.
Today is the beginning of a new era. The landscape changes. We begin building an icon for our state. Today, Arizona wins.
As the oldest continuously run professional football franchise in America, the Arizona Cardinals have never had a stadium to call their own. In 2000, the Cardinals scored a major victory when Maricopa County voters passed Proposition 302, which increased hotel and rental car taxes to help fund the stadium project. While the funding became a reality in 2000, the vision for a new stadium began to take shape a few years earlier. In 1997, Cardinals ownership Bill and Michael Bidwell explored the possibility of retaining an internationally known high design architect for their future stadium project. And their search uncovered Peter Eisenman, not only one of the most influential architects of the 20th century, but a passionate football fan.
I didn't know anything about all this going for a high design architect, right? Some guy called me up, said, "You remember me?" I didn't remember him. He said, "Are you interested in football?" Right? And I said, "Yeah, I'm interested in football. I'm going to 2 games this weekend." He said, "Uh-huh." He said, "Well, I represent the Arizona Cardinals, and this is the 50th anniversary of their championship." And I said, "Hey, I saw those guys play, and I can even name you the backfield," right? And I did. I named the backfield just off the top. I don't know how I did it, but I went boom, 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 like that. The next day, this guy calls me back, and he said, "Can you be in Cincinnati on Sunday to see the Cardinals and the Bengals game?" And I said, "The Giants are playing at home." And he said, "Yeah, but the owners would like to meet you." I said, "Yeah, I'll be there."
As the project evolved, the Cardinals expanded the design team by retaining the services of HOK Sport, the renowned sports architecture firm that has designed more NFL stadiums than any other firm. HOK has been at the forefront of the shift from the cookie-cutter multi-sport stadiums of the 60s and 70s to the more sports-specific stadiums of today.
In the mid-60s, there was the idea, because cities had 2 professional sports teams, that they could coexist, and for a while that worked because the city then had to spend its dollars on one building, and since the season didn't overlap to any degree, that worked. But with the needs of each specific sport, really purpose-built buildings, ballparks for baseball and football stadiums for football, really became a necessity for a variety of reasons.
Contrary to stadiums of the past, designers of modern venues have set out to create structures that do more than just accommodate thousands of people. Rather, they're seeking to create buildings that are a reflection of the city and the teams they're built for. With this concept in mind, the Cardinals set out to build a stadium that would not only reflect the unique beauty of the Arizona desert, but be a significant and enduring contribution to the ever-evolving urban landscape of the Valley of the Sun.
we as architects are very, very concerned about is that our buildings are in fact contributions to the culture of the time, that they're not just an attempt to remember a kind of fictional golden age, but they make today special and important.
While Eisenman's design has a modern look and feel, elements of Arizona's Native American culture and unique desert landscape are evident in the stadium's exterior shape. He drew inspiration from two common features of the Arizona desert, the barrel cactus and the snake form.
When you see the stadium, it ends. There's this end, and then the thing radiates around and gets flatter, gets thicker and flatter. That's the residue of the snake form, and incorporated with it is a mandala form, which is a center radiating out. So these spokes are like a mandala or a spiky cactus, any kind of organic form that radiates from the center.
One of Eisenman's primary challenges was to have a high design concept throughout the project without interfering with the fan experience. He was able to accomplish this by using a unique exterior that features alternating metal panels intended to reflect the shifting desert light alongside magnificent vertical glass slots, allowing patrons a spectacular view of the horizon from any level of the interior.
Between my seat and when I leave my car, that's where architecture comes in. And I think from this stadium, you can be both inside looking in a concourse, looking at the game, and looking out at the buttes and the mountains. I think that's a great feature. Not many stadiums have that possibility.
During the early stages of the stadium's metallic skin installation, its unique reflective nature was already apparent in many ways.
Depending on the angle of the skin, it's very reflective of a gray day, a bright sunshiny day with the blue sky, or if there's a tremendous amount of vegetation, there'll be a greenish tint to it. Sunset, you'll find a different color to the building, so it's always changing. It's a little more, organic in that sense, and it's somewhat alive.
In addition to the exterior skin, the retractable roof was another major component of the design. While recent stadiums have incorporated retractable roofs, this design called for the roof panels to move along an arc, an engineering first.
The operable roof is the second one that we've done for an NFL building, Reliant being the first, but this takes some steps which are different. It would have been easy just to repeat sort of a flat roof, flat tracked approach. This more, the operable portion of the roof takes more the shape of the building itself, and so the panels actually flow down the sides of the building and then together in the center.
Working on covered sports stadiums is nothing new for the structural engineering firm of Walter P. Moore. They were involved in the construction of the world's first covered sports stadium, the Astrodome, built 40 years ago, as well as two of the most recent retractable roof stadiums, Minute Maid Park and Reliant Stadium in Houston. In designing the trusses that would serve as the support structure for the movable roof in the Cardinals Stadium, Walter P. Moore drew inspiration from a 19th century engineering legend.
Knowing some of the engineering history here, we noticed as this roof form was evolving that these trusses were very similar in shape to a bridge called the Royal Albert Bridge, completed by the very famous British engineer named I.K. Brunel in 1859 in England. So just to introduce a little sense of history into the project, we dubbed these the Brunel trusses.
The two Brunel trusses provide a rigid line of support beneath the tremendous moving loads of the retractable roof. They are lenticular in shape, similar to the shape of a football, and measure 87 feet at their tallest point. Over 700 feet long, each truss is just slightly longer than the length of 3 Boeing 747s. With the shape of the Brunel trusses, Walter P. Moore was able to create a roof support system that was cost-efficient and visually dynamic. Engineers had to balance Eisenman's architectural ambition with physical and budgetary boundaries.
The geometry of this roof system was very important to him, since all this structure is exposed, and when you're sitting there, at halftime, if you don't like what you see on the field of play, your eyes are looking up and you're looking at the structure. He wanted that to be a pleasant experience, and he wanted it to look look right.
A lot of times the aesthetic vision has to go through a process of reconciling with the physics of having a 700-foot long span roof, and also some of the functional considerations of the stadium venue itself. The primary driving element on the Brunel trusses is how deep they are at the center. That really drives the economy, and where we ended up was at an 87-foot deep truss that allowed the aesthetic vision of the architect to have a fairly low profile roof on the top. It has enough depth for us to design an economical truss, but yet keeps the bottom element out of the sight lines of the bowl itself.
The next step in the assembly of the roof support was the acquisition and fabrication of the steel used to construct the Brunel trusses. Designers targeted a specially milled high-strength steel made by Trade Arbed of Luxembourg, one of only 2 companies to produce this type of steel worldwide.
Engineers like to use that in long-span structures like this because they get a savings for strength versus weight. So for the same weight as a non-high-strength steel that would be, say, produced domestically, they can carry a lot more load over a certain distance. So there's obviously a price premium, but in overall there's a big tonnage savings. And in any long-span structure, especially one of this complexity, you want to keep that weight down to a minimum.
Phoenix's Schuff Steel, the project steel fabricator and director, began to assemble the trusses in 20 by 20 foot sections at their own facility before transporting the sections to the stadium site. Once at the site, the sections were welded together atop temporary shoring towers on the stadium floor. Assembling the Brunel trusses on the ground dramatically improved efficiency.
If you were going to build it in the air, you had to have much more of the concrete structure in place to support the shoring towers and the ends. So what we looked at was a way to get about 60% of the concrete work in place, get one end of it up and out of the way, let the 2 Brunels start from the north end and work their way to the middle, while we were finishing the concrete work at the south end. So building them on the ground made a lot of sense. We got started probably 3.5 to 4 months earlier than you would have done it if you were waiting for the entire concrete frame to start.
The support system for the 11.2 million pound roof assembly consists of 4 high-strength concrete super columns, one at each corner of the stadium. Each column measures 171 feet tall, 17.5 feet wide, and nearly 12 feet deep. The dimensions of the columns required 1,050 cubic yards of especially mixed high-strength concrete. As the structural engineer of record for the concrete work on the project, TLCP oversaw the design and construction of the 4 super columns.
We use a 7,000 psi strength concrete, where typically residential construction would be more in the 2,500 to 3,000 psi. So it's a high strength mix to give us the strength that we need to provide the support for this lift and for the serviceability of the building.
The super columns were engineered with the roof raise in mind. Designers incorporated a channel which runs the entire 171-foot height of each column, allowing the Brunel trusses to have an unobstructed and guided path up the columns to their ultimate position, 156 feet above the stadium floor.
The super columns are designed actually to support the lift. That's why the notch is in the super column, to allow the Brunels to be lifted to the overjack position. And the notch is there, then the support girders will be slid into place. And once they come down, sit on the girders, then the columns are there for the service support, or the support of the roof for the life of the building.
The company contracted to perform the lift of the Arizona Cardinals Stadium roof assembly is Mammoet, a Netherlands-based firm that specializes in lifting and transporting heavy structures. Overseeing the lift for Mammoet is Jack Toll, who has worked on several similar projects throughout the world.
Actually, we have it pretty easy on this job. Our responsibility is just to go up with it. It's the other companies that are involved that monitor the deflection of the roof, the super column deflection, that have an influence on what we do.
Mammoet gained worldwide acclaim for its role in the retrieval of the Russian nuclear submarine, the Kursk, which had sunk to a depth of 108 meters on the floor of the Barents Sea. The centerpiece to the successful salvage operation was Mammoet's advanced computer-controlled strand lifting systems, designed for safe, precise, and heavy lifts. Mammoet plans to use the same system to lift the roof assembly for the Cardinals stadium. The strand jack is a hollow hydraulic cylinder that uses a gripping system consisting of wedges and cables to lift or lower massive objects. The jacks on this project contain 54 tubes, each housing an individual steel cable called a strand. Attached to each strand are two gripping wedges located at the top and bottom of the cylinder. The gripping system is similar to the hand-over-hand motion used to raise a pail of water from a well. When lifting, the hydraulic cylinder extends, forcing the top wedge into a cup, causing it to tightly grip the strand. As the cylinder expands and completes its stroke, it raises the strand and the object that it's attached to. At the end of the stroke, the bottom wedge is engaged, securing the strand, while the top wedge is released, allowing it to be repositioned for the next stroke.
Each super column, and there's 4 total, contains 2 strand jacks. Each have 1,000 US ton capacity. The roof is estimated to weigh 5,500, and we have 8,000 ton capacity, so there's plenty of safety margin in it.
Each pair of strand jacks is mounted upon yellow temporary jacking frames atop each super column. The 3-day plan calls for all 4 corners of the roof assembly to be raised at a synchronized rate from their initial bearing point at the main concourse level to the notches near the top of the super columns.
Once we get the go signal, our operator will use a computer that drives each jack separately and keeps control of each jack. And the computer makes sure that each jack will not stray from the other jack.
At the controls of this monumental lift is Jason Marks, who is positioned with a laptop computer inside of a small room on the upper concourse of the stadium. From his laptop, Marks is able to monitor and control all 8 jacks simultaneously. His job is to raise all 4 corners of the roof assembly in unison to ensure a balanced and safe lift operation. While the cozy control room shelters Marks from the elements, it does not protect him from the creative nicknames that his co-workers have given him.
I've been called all kinds of things. Because a lot of times when we're putting things together, hanging jacks, cutting wire, working, it's all different. But when it's time to get in the box and everybody starts giving me a hard time, call me box boy, mouse boy, the train gorilla, I've heard it all. They'll come in there and walk by and throw me bananas, tell me to push the button.
Mammoet's technical expertise is not the only reason that their work is known around the world. Wearing their trademark bright red jumpsuits, their crews stand out from the typical construction crowd. With an eclectic mix of international personalities, Mammoet crews leave a lasting impression on those they work with.
They're all in their red jumpsuits, and they kind of appear on the job site, and they're here for a couple of weeks, and then all of a sudden they pack up their stuff. They're kind of like a really high-tech circus comes to town.
Very good group of guys. They work all around the world. They looked at us kind of like we had 3 heads once in a while, and we talked about the things we were planning for. And to see us sit down here trying to calculate, inches of movement, and all they wanted to do was pick it up. And I said, why wait?
They're just, wasting time. We might as well go on up.
I understand you've reached the choir. Just hang in there for a little while longer.
From the beginning, this is clearly what they do. They have the technical expertise. We couldn't be happier with Mammoet. They were everything we thought they were and more.
As the general contractor for the project, Hunt Construction Group assembled and coordinated the efforts of the various subcontractors working on the roof lift. With over a half-dozen subcontractors involved, careful planning was essential. One of the major objectives of the 13-month planning process was to prepare the lift team for all the potential scenarios that could arise during the operation.
You can read a lot of the trade journals, and you know that some of these that have gone up haven't gone so well. We pride ourselves in working with the fabricator, the erector, and the general contractor to plan an event like this and play the what-if game and try to anticipate all the problems that could come up and then get solutions for them and have them thought out ahead of time. There's no question that of all of the long-span roofs around the country we've been involved in, this is one that has been planned in more detail than any other, and I think this project will probably set a new standard for that.
Officials planned for communication flow and chain of command procedures to filter through a control room located on the upper concourse of the stadium's north side. Inside the control room, representatives from each of the key subcontractors could monitor critical data and relay instruction to field personnel during each step of the lift process. The first step in the lift operation is to raise the roof assembly from the yellow temporary shoring towers, allowing the Brunel trusses to be fully suspended. Then the roof will be raised approximately 7 feet in order to attach transfer girders to the ends of the Brunel trusses. The third step is to lift the roof assembly with the attached transfer girders to the overjack position, slightly above the notches in the super columns. Next, workers will swing the transfer girders into the notches in the super columns. Finally, the roof assembly will be lowered to rest upon the transfer girders and be welded into place.
First day's activities will start out down at field level. On a daily basis, I've got 5 gangs. We're calling them quad gangs, A, B, C, D, and then a roving gang.
As Director of Field Operations for Schuff Steel, Ron DeBenedictis, a 32-year veteran of the industry, would lead a group of 50 iron workers during the roof lift. Their first task was to remove the bolts that secured the trusses to their temporary shoring towers, while detensioning the guy cables that held the shores to the stadium floor.
Once we've removed all of the bolts, the nuts, the washers, and the guy cables, and Mammoet begins the lift operation, we're going to be clearing the first shore towers, and those are at the extreme ends of the end zones.
At approximately 10 a.m., officials completed their final safety checks and determined that it was clear to commence lift operations. With the lift underway, the roving gangs positioned themselves at the outer edges of the trusses to look for evidence of separation from the shoring towers.
Wes, what do you got for, how much daylight you got over there? We're going to start working your jacks.
3/4 on the east side, 3/8 on the west side.
All right, we're going to call that good.
Once we clear daylight, the engineers and the consultants up in the control room will perform some inspections and some monitoring activities, and once we get the all clear, we'll repeat the process over and over again until we've cleared the final shore towers at the center or the 50-yard line.
Yeah, let's move over to 2.5. You guys that are observing, going to start looking to break loose on these next shores.
Clearing the shoring towers was a time-consuming process, as engineers were intensely calculating the first movements of the trusses.
All right, we're waiting for these guys to crunch the data up there. They'll give us the word when they're ready up in the control room, and then Dave will be doing his thing again here.
They wanted to make sure that the roof assembly was moving in a manner that was consistent with their projections.
And we expect to see about 16 inches of movement at the far ends of the jacking operation before the center of the truss ever comes off.
Even though the Brunel trusses and the super columns are extremely rigid, engineers predicted that both structures would show movement as they assumed the weight of the lift. They expected the trusses to sag in the middle, while the super columns would deflect inward. In order to ensure that the structure was behaving within its limitations, engineers were analyzing data relayed from monitoring devices placed at strategic points on the trusses and super columns.
The monitoring has been set up via strain gauges and deflection monitors. We're getting constant feedback from the strain gauges, and every so often we'll get deflection updates that tell us how exactly specific points on that truss are reacting as we pick it up and move it off of the panel points.
A strain gauge measures the amount of stress that is placed upon the steel members of the Brunel trusses during the lift operation. 76 strain gauges will be utilized during this lift.
Okay, I've been told to hold off for a little bit to check in the strain gauges.
It's got a grid system on the gauge that when the gauge is actually strained or pulled in tension, those little wires neck down and changes the resistance of the gauge, and therefore the data acquisition system can actually measure that change.
Engineers in the control room could measure the deflection of the trusses and super columns by analyzing data acquired from a system of 2 survey stations located on the stadium's upper concourse and 56 precision targets placed on the roof assembly and super columns.
We've applied what we call prisms that we use an instrument called a total station to measure the distance between each of those prisms and calculate back what the truss has moved.
We zoom in and we get a reading. We establish a baseline when the Brunel truss was in the relaxed position on the floor, so that we can tell deflection and elevation from that.
We're just monitoring it to make sure that it moves as a unit as opposed to moving independently. You know, if one corner isn't going up higher than the other corner, making sure we get a nice consistent lift.
They have their model as where it's supposed to be, so they can take our information, plug it right in, and get real-time data on the deflection and on station and offset.
During the early hours of the lift, engineers continued to monitor and analyze the slightest movements in the trusses. They realized that this would be a critical time period as the roof assembly continued to take on more of its own weight.
That's where all the observations, inspections, and monitoring is going to occur, and that's where we're likely to find the noises, the sounds, the creaks, the groans, the popping sounds that are natural. You hear that whenever you flex steel, and as large as the structure is, you're going to hear some of that.
So you're looking all right so far, huh?
While the popping sounds emanating from the roof assembly were anticipated, veteran ironworkers felt a heightened level of anxiety as they worked inches away from the shifting steel.
Daylight all the way around.
Daylight on quadrant all the way around. I got my pants.
It's a good thing you're by yourself. Ain't nobody getting near you.
As the lift operation progressed into the afternoon, steady rain began to fall, which proved to be nothing more than an inconvenience. The weather would have no adverse effects on the strand jacks, the same jacks used by Mammoet in the Kursk salvage operation.
Rain is absolutely no problem. The equipment is fine. It was in the Barents Sea with big waves going over it and all that. This equipment has seen a lot worse than what Phoenix can throw at it.
The weather may have had little impact on the equipment and the engineers in the control room, but ironworkers had to labor through Mother Nature's ill timing.
Look at that. I knew as soon as our shift started, it started raining.
The weather's definitely affected the guys. They're kind of in more of a hurry to get this thing over with. They're a little wet, but it is the second shift and they're coming on fresh, so they've got a good mindset to get this thing in and done and behind them.
As they battled the elements, the trusses continued to inch upward, and the ironworkers turned their attention to the installation of the transfer girders.
We're looking to come completely off of the shores, and then we'd like to go to 7 feet above this main concourse and be able to take the transfer girder assembly and slide it underneath the end assembly, lash it on the end of the end assembly here on the pickups, and be prepared for tomorrow to be able to continue on up with the lift.
After 5 hours of lifting, the trusses had enough clearance for the ironworkers to construct a track system to move the 20-ton transfer girders under the end assemblies. Once the girders were under the end bearings, they were attached to trailing cables hanging from the trusses. With the girders securely in place, the sun finally set on day 1 of the lift operation.
Weather we're going to have to contend with today. We need to watch our step. You know, you guys stay in real close communication with your foreman, with each other.
Steady rain fell throughout the night and into the morning of the second day of the lift operation. While movements came slowly on the first day, engineers plan to cover more ground on day 2.
We'll probably start out fairly slow, and if everything's going well, we'll crank up the speed and go a little faster. Probably at the most we'll go about 20 feet an hour. It's still going to be extremely slow and pretty boring.
While much of the lift is monotonous to the casual observer, the ironworkers are in constant motion. With the lift progressing smoothly, ironworkers moved into the next phase of their plan. They needed to attach mounting hardware for chain falls and come-alongs that would be used to swing the transfer girders into place once they reached their final bearing points in the notches of the super columns. Experienced ironworkers make this type of operation look simple. However, working with this many moving parts in this type of environment can be dangerous and requires exacting precision and teamwork.
We need to stay safe, so keep an eyeball on each other, take care of each other up there to begin with.
Any successful team relies on the experience of their leaders. According to the ironworkers, there's no better leader in the business than Schuff Steel's Ron DeBenedictis. Throughout his long career, he's earned the respect and the admiration of everyone who's worked with him.
He's a unique type of guy. He's a real hard pusher.
You guys need to be aware of how this blocking is. There's 2 blocks on each side.
He's got a great personality. He's a real joker. You know, likes to not afraid of a prank.
Did you clean everything up last night?
Oh, that was it.
Yeah, okay, sure.
Yeah, right. I've worked with very few with the knowledge and the experience that he has. And he's a good person to work for, too.
You got those guys give you those ideas, this is how we should do it. Well, everybody thinks they know how to do something. Ron's pretty much done it.
His way is the right way. That's why. There's no problem there. I mean, this is a prime example right here. A whole bunch of guys teaming up and behind a real good plan from somebody who knows how to plan.
As the roof assembly neared the halfway point, Mammoot's technicians noticed a malfunction with critical pieces of the lifting mechanism and were forced to stop the lift.
Mammoot has run into a problem down on Quad C where their wedges that run the cable strands, they've had some failures, so they're going to go and replace them. It's not an uncommon situation, but being that it's late in the day, the amount of time it's going to take to do the lift for the rest of the day, we've decided to block off the truss and block the roof in for the night, and we'll return in the morning and go back to work.
Mammoot's technicians determined that a loss of traction between some of the wedges and the strands was a result of a bad batch of wedges. In the event they would need to replace all 864 wedges, Mammoot made the call to have a complete set of backups shipped overnight from their offices in Rocheron, Texas. Day 3 of the lift began with Mammoot technicians examining each individual jack and wedge for signs of wear and tear.
We're doing maintenance on the wedges. That's the device that grabs the cable. And them things wear out. At this job, for some reason, they wear out a little quicker than they're supposed to. So we're just going to check them all and change them out if we have to.
So what we're doing today is the wedge itself. We're individually, one at a time, we're taking them out and inspecting them. And what we inspect for is the grip. And it's basically the wear, visual look that the technicians will see. If they see wear in it, then we're replacing the wedge.
While the mechanics worked to identify all of the damaged wedges, other members of the Mammoot crew helped out by preparing the newly arrived replacements in case they were needed.
We had allowed for a contingency day, which was for maintenance or anything else, weather or wind or whatever. And so day 3 today is maintenance, and that's kind of going to fill our day. And we'll get that finished up sometime late tonight and be in lift mode tomorrow morning.
The ongoing repairs put the lift operation on hold, but didn't stop onlookers from gathering outside to observe the historic event.
This stuff is just draws everybody's attention. It's a big deal for this area and the west side.
I think it's kind of impressive. I had no idea it was that big, and saw it on the news, and we drove by and said, hey, let's take a look, and a lot bigger than I thought it would be.
Members of the stadium construction crew who weren't directly involved in the lift were also impressed and came out on their day off to observe the event.
When you're working on it, you get a sense of pride of what's going on, and you want to see it work out. So you're kind of interested in seeing every aspect of it going up instead of just what you do. You know, I really want to be one of the first people to be in there, I really do, because when you put all the hard work you put into the stadium to make it what it is and what it's going to be, you know, you kind of feel a lot of pride in what you've done. And you want to take your family in there and say, look, you know, this is what we built.
Meanwhile, back inside the stadium, Mammoot crews worked diligently into the night to put the finishing touches on the repairs with the hope of resuming the lift in the morning.
We'll get into lift start. Everybody go through their checks, and then Mammoot can proceed, and we'll go to 156 and then above. We're looking at going over jack.
Yesterday's maintenance day went very well. Mammoot changed out a number of wedges on a number of their jacks, and everything went smoothly. In fact, they finished ahead of schedule. They started early in the morning at daylight, and were done by about 8:30 last evening.
With the maintenance issues taken care of, lift operations resumed and slow and steady progress was made over the next several hours. As the truss neared its final destination, ironworkers began to ready the chainfolds and come-alongs to swing the transfer girders into place. The notches in the super columns were designed to accommodate the installation and support of the transfer girders. Measuring 6 feet tall, 17.5 feet wide, and 5 feet deep, the notches were embedded with 12 bolts that will be used to anchor the girders in place. Once at the overjack position, 163 feet above the stadium floor, the trailing cables will be released from the girders, leaving the chainfolds and come-alongs as the only support. The workers will then use this system of pulleys and chains to carefully drift the transfer girders into the notch. The girders will then be lowered onto the anchor bolts, where they will be welded securely into place. Once this process is complete, the entire roof structure will be lowered into its final position upon the transfer girders.
When we lower the truss system on top of these transfer girders, then it's time to start relaxing a little bit.
Hey! Are you even down?
Before the ironworkers could relax, they would embark on perhaps the most challenging task of the lift process. Crews would need to position themselves on all sides of the transfer girders in order to have a successful installation. Workers accessed the backside of the transfer girders by rigging 4 sky climbers. They moved into place with ease via the super column channels that previously housed the strand jack cables. Crew members tethered to the trusses manned the come-alongs, while others on temporary scaffolding operated the chainfolds.
Ironworkers, by their very nature, are very competitive people. They're high-spirited. They like doing what they do. They build these buildings and take a lot of pride in what they do. I predicted it to one of the project managers. I said, I can see this coming. There's going to be a contest to see who can go in first, and that's how it went. I mean, these guys were in there. They were working their tails off to get these things in first, second, third, and fourth. And, you know, there was no prize at the end, but the pride of who did it first, and I think they really enjoyed that.
With the transfer girders welded into place, the 700-foot-long, 11.2 million-pound roof assembly finally touched down into its final position. As the backbone of the roof structure, the successful installation of the Brunel trusses set the table for the roof to be completed with the placement of secondary trusses in the months following the roof lift.
What you're about to see is one of the marvels of modern engineering and stadium building.
Cardinals are getting a new stadium built in Arizona just outside of Phoenix, and yes,
it's the ultimate raise the roof party. It's being called the largest single roof lift in North America.
What began as a 3-day project ultimately took a little over 4 days to complete. Even though the lift took longer than originally anticipated, it was praised as a highly successful endeavor.
Well, I've been working on it for a couple of years now, and this is the first time I've seen it up in the air, and it's awesome. It's just awesome. You're not going to see anything like this again.
Well, it's kind of a dream, lifetime dream, you know. You don't get a chance to do one of these every couple of years, you know. This is probably the biggest one project we've ever done, and we're just real happy to be a part of it.
Watch it come together on paper, and then you watch it being planned, and then you watch it go together on the ground, and then you actually see it happen. And all the man hours of planning that went into it, it's very satisfying to see it come together and be a success.
We see this stuff all the time, but we don't see this magnitude of lifting and these spans, and this is as exciting as it gets for us.
After the weekend was over, it was really the first chance I had to see it in the daylight, and it was quite a sight. You know, being here all weekend long on all the concourses running around inside the bowl. It's a different perspective once you get outside. It's just amazing.
For us, this is a Super Bowl. It doesn't get any better than this. This is just a terrific, unique piece of work that we've all had a great opportunity to really do something different and have your plan come to fruition and be successful.
With the SuperLift in the rear view mirror, construction officials could relax momentarily before they shifted their focus to the completion of the stadium.
It took us to a second phase of construction, which is what we call the finishing touches. We're now trying to finish up the roof and finish up the exterior, getting closed by the end of the year, and give us the last 10 months to do interior finishes and get ready for the August '06 season.
When this trend-setting stadium opens its doors for the first time, it will set a new standard that will be copied and admired for years to come.
It blazes some new territory in what the image of an NFL building might be.
It's got the sliding field. It was a different way to do an operable roof. It has simplicity, which I look at a lot as to how can we accomplish more things by keeping things simple, less costly, and then how can we do more with that? And I think this building is evidence of that.
Important stadiums are copied, and so we'll see stadiums all over the world that have echoes of this. It'll be one of the stadiums that provides a kind of model for the next generation of stadiums all over the world.
Time is the test for these kinds of projects. And how will history record this moment? I think pretty well. I think 100 years from now, this will stand the test of time. And I think that's what we're looking for, a stadium that wasn't just new and exciting today, but what will be new and exciting 100 years from now.